Okay, so we're going to talk about the derivatives of trigonometric functions. Up to now, we've looked at, basic stuff like derivatives of sums and differences, derivatives of constant multiples. We have like the power rule for derivatives of polynomials. We have the product rule and the quotient rule, so you can take the derivatives of rational functions. Now we're going to do our first non-standard, more complex derivative, the derivative of trig functions. So let's go into writing mode. Okay, so let's just start off with, let's say you want to take, so I guess we'll just start by reminding ourselves that if you want the derivative of something, you're going to do the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so let's say that you wanted to take the derivative of sine. So what would you have to do? You'd have to do the limit as delta x goes to 0. Remember, delta x or h is the same thing. So you would want the sine of x plus delta x minus the sine of x all over delta x. Okay, so instead of actually computing this limit, let's estimate the limit. By setting delta x, oops, that's not what I wanted. Oh, there's a way to do the delta. Where's the delta? Oh, there we go. Apparently on the Mac it's Alt-J. By setting delta x equal to something close to 0, like someone choose a number close to 0 that we can plug in for delta x. Like, how small should we go? Give me something. Give me a value close to 0. Someone. .001. Awesome. So, if we choose .001, we know that the derivative of sine x, whatever it is going to be pretty close to the sine of x plus 0.001 minus the sine of x all over 0.001. Okay, so this is pretty close to the derivative of sine. Okay, and what we're going to do is we're going to go to Wolfram and graph that and see what it looks like. Okay, so one second, I'm getting my Wolfram ready. Having a hard time changing the screen. Boom, okay, there we go. So, our f of x was sine. Okay, so let's call this d of x for derivative. The derivative is pretty close to the sine of x plus 0.001 minus the sine of x divided by 0.001. Oh, okay, I can't call it that. Let's just say call it derivative. Let's call it der for derivative. So let's plot them. So we'll start by plotting f of x, sine. And let's plot it from minus pi to pi. Okay, so does everyone see the graph of sine right there? Okay, now let's plot what its derivative appears to be. Okay, so the derivative is the one in orange. It looks sort of orangey, yellowishy, right? Okay, looking at this, what does that derivative look pretty close to? Like if you look at the blue one is sine, The orangish one is its derivative. What does that seem to be close to? If you look at that graph right there, I guess let's extend it from minus 2 pi to 2 pi. Let's just go back. What does that look very close to? This one right here, the orangish one. Yeah, it's close to being the cosine graph, exactly. So let's copy the graphic, go back to OneNote, there we go. Yeah, it's way too big, let me change that. Okay, there we go, nice. Okay, so what we have here is, in blue, we have sine, and in orange we have our approximation to the derivative of sine. And that looks like it's cosine, and in fact it actually is. The derivative of sine is cosine. Like, just like I'll tell you, like that is what it is. So looking at this, oddly enough, like when you set delta x to be pretty small, this basically is cosine. Okay, so we're gonna look and figure out, like, how do you actually calculate the limit and get cosine? Does that sort of make sense to everybody? Like, how do you actually get that? So let's do that. So we're gonna do the limit as delta x goes to 0 of sine x plus delta x minus sine x all over delta x. Okay. Does anyone remember the sine sum identity? If you have the sine of a plus b, what does that end up being? Does anyone remember? Does anyone remember the trig identities? If you want the sine of a plus b, what can you rewrite that as? Yes, it is the sine of a times the cosine of b plus the cosine of a times the sine of b. So what we're going to do is work on the numerator of this. What we're going to get is the sine of x times the cosine of delta x plus the cosine of x times the sine of delta x. Okay, good so far? And we have minus the sine of x. So if you look at these two terms, they share sine in common. So you can factor out a sine x, and you get cosine of delta x minus 1 plus the cosine of x sine delta x. Did I do that right? Yes. Okay, cool. Okay. So let's put that back into the limit over here. You get the limit as delta x goes to 0, and then that's going to be split up into two different fractions. One of them is going to be sine x times the cosine of delta x minus 1 all over delta x. And then this one is going to be minus the cosine of x sine delta x all over delta x. Oh, let's move all this. so it doesn't get stuck. Okay. So we can break this up into two separate limits. Okay, so one of your limits is going to be the limit as delta x goes to 0 of cosine delta x minus 1 over delta x. Now, the delta x is the variable. Notice that this is sine of x. X is a constant because delta x is going to 0. So I'm going to be moving the sine x out in front. Likewise, you get another limit. The limit as delta x goes to 0 of sine delta x over delta x. Delta x is going to 0. Delta x is the variable, so this cosine can go out in front. It's a constant. The x is a constant. All right, so the cosine of x is a constant. You can use the constant multiple rule to factor it out. Okay. And these are actually two special limits. This limit of we can just rewrite this as the limit as x goes to 0 of cosine x minus 1 over x. And we can rewrite this as the limit as x goes to 0, so we don't have to write the delta x of sine x over x. And then we're going to use Wolfram to estimate what these are equal to. Okay, so I'm going to go over to Wolfram, and we're going to use the table function to do the estimation. So let's do the first one, the table of cosine x minus 1 over x. Okay, and we're going to be going to 0, so let's plug in numbers approaching 0, like 1, 1/2, 0.1, 0.01. Oh shoot, my bad. I thought I switched. There, can you see that typing it in now? That got table cosine x minus 1 divided by x. Cool. And then we want our values like 1, 0.5, 0.1, 0.01, 0.001. Okay, we run that and we see what we get. As you're getting closer and closer to 0, what do the values of the thing seem to be going towards? Can we see it? Let me make it bigger. Oops, there we go. So as your x values are approaching 0, what do the y values in the table seem to be approaching? What are they going towards? Can we see it? Yeah, they seem to be going towards 0. So let's switch back. Okay, so this limit, this one seems to go to 0. So what you get is sine x times 0 for this term. So that's just going to go away. Now we have to do the other one. We'll do the limit of sine x over x. Okay, 1 second, I'm like stuck. Why is it not changing? Sorry, switching the Windows is really annoying. There we go. Okay, now let's do the same thing. I'm just going to copy this whole command. And the function that we're going to be, we want to do sine x over x. So you can see here's my sine x over x. We want the x values to approach 0. So if you look at the y values of sine x over x, what do they seem to be going towards? Yeah, they're going to 1. so this limit seems to be heading towards 1, so you get minus cosine x times 1, which means our derivative of sine ends up being, ooh, it should not be minus cosine. I made a mistake somewhere. That should be a plus. The hell? Oh, yeah. This is a plus. So that's a plus. That's a plus. So you get plus cosine. There we go. Sorry, I had an extra negative somehow. So that's how you actually get the using the limit definition. We did the limit of sine x plus delta x minus sine x over delta x. We went through, we did some trig substitution, or trig identity stuff, my bad. We split it up into 2 limits, and then we looked at each of these limits numerically in Wolfram. We found out that the limit of sine x over x was 1. The limit of cosine x minus 1 over x was 0. Because the one on the left was 0, all that term went away. And then we were just left with this cosine right here, which gave us our derivative. Okay? So, I'm not going to go through the derivation of the other one, but the derivative of cosine is minus sine. So, sine and cosine are derivatives of each other almost. The derivative of sine is cosine. The derivative of cosine is minus sine. So you have to remember that. You could prove it just like how we did, just like right now with the limits, but we're not going to. It's like a lot of work to do that. We already spent a good amount of time doing this. Okay, so you have your first 2 rules about how to take the derivative of trig functions. Let me pause to see if there are any questions. I'll have people if I need to like scroll up or anything. So I'm going to pause for a moment. Are there questions?